Okay, hello team. This is a video where we just look through the power law practice problems that were set for practice work. So let's get straight into it. So our first one is model choice from the 2017 VCAR exam. The average rate of change of the function with the rule f of x is equal to x squared minus 2x over the interval 1, a, where a is greater than 1 is 8. Find the value of a. Multiple choice. So it's average rate of change, so it's not instantaneous. There's a function over the interval 1 to a. So we're going from some point x is equal to 1, and we're going to some point x is equal to a, and we want to find we're told the average rate of change is 8, find the value of a. So rate of change average is equal to f of b take away f of a divide by b take away a, where b and a are any placeholders. And the annoying sort of thing here with this is that we've already also got an a, so just to avoid confusion, let's just call this f of, no, not e and f, because we've got f of e, h, g and h, g, h, g take away h, where the first point is h and the second point we're going to ABCDFG. No. The first point is g going to this ABCDFG h, yes. First point is g going to h, and I need to change the order of these. Okay, ignoring the times up because I'm explaining how to do this. So we just need to substitute in our data, and we're told in this case our rate of change is 8. So we're going to substitute them in. So we're going to let a equal to h, yes, and 1 is equal to g. So we're going to sub that in. So f, we need to find f of a, which is equal to a squared minus 2a, and we need to find f of 1, which is equal to 1 take away 2 is equal to negative 1. So we can substitute those in. F of so we get a squared take away 2a, and then that was our f of h, our f of g, which is f of 1, take away our negative 1, divide by a take away 1. So we're going to get a squared take away 2a plus 1 on a minus 1, and we know that's equal to 8. I'm betting that we'll be able to factorize this, the top, so we get a. We get take 1 over a take 1, put that in brackets, one of those cancels, so we get a take 1 is equal to 8, so we get a is equal to 9. This is a. Quick thing to note, I've added in here these after, if they are prior exams, just as a reminder, if exam 2 is tech free or tech active, so exam 2 is a tech active exam. So you could have also done this with your calculator, so instead of having to do all this sort of factorization, you could have, and that, let's actually do it on the CAS instead of me writing it out. You could have defined f of x is equal to x squared minus 2x, done, and you could have then just gone fraction f, really shortcut it, could have gone solve fraction f of a take away f of 1 divide by a take away 1, and we were told that all of that was equal to 8, and we're trying to figure out what a is. No, we're trying to figure out what a is, and that's told us a is equal to 9, which was the answer we got, and done. So that's how you could have done on the CAS. Right, a whole bunch of notation. The first couple are pretty simple. We've got no denominator and that we need to worry about factorizing out. So to solve a limit, then we just substitute in. So this is going to be equal to 5 by 0 cubed plus 6x by 0. So we're just putting in h is equal to 0 plus 2 by 0, and that happens to be 0. Makes everything 0. Same thing for part B, that is equal to 2. Actually, this is, you need to be really careful. This is asking for the limit as h approaches 0, but there's no h's in here, so we don't have anywhere to substitute that h into, so all we're left with is 2x squared plus 7x minus 1. So that's that. Now, C and D, we have a h in the denominator, so we can't just substitute 0 into the denominator, because we can't divide by 0. So this is equal to the limit as h approaches 0 of, take h out of the common factor up the top, 6x plus 3h plus 2, all divided by h. Now we can cancel the h in the numerator and denominator, and we are left with is equal to, I might just write it out anyway, just to show it on this one, of 6x plus 3h plus 2. So now once we substitute it in, we can stop writing this limit. Just as a reminder, until we do the substitution, you must write those limit words. So substitute it in, and we get 6x, because we're putting in h0, plus 3 by 0 plus 2 is equal to 6x plus 2. Same thing over here, we have to factorize, so this is equal to the limit as h approaches 0 of h negative 3x squared minus 3xh minus h squared, all divided by h. Cancel. And we can substitute in the 0 where there was a h left over, so we get negative 3x squared minus 3x by 0 minus 0 squared, so that just leaves me with negative 3x squared. All done. Right here, so that was some limits. Finding the gradient of a tangent, so now we're actually going to using the power rule, so the graph we're told is x squared minus 4x plus 4. Find the gradient at the point 3, 1. So first thing we need to do, as it says in the step, is we need to differentiate the equation. So f dash of x is equal to, and what's the power rule? Just as a reminder, if f of x is equal to x to the n, then f dash of x is equal to n minus 1. So all you're doing is multiply by the power, whatever the power is, and then take 1 off the power, and that's your derivative. So we have x squared, so times by the power, so we get 2x, and then the 2, take away the 1, just becomes 1, which we don't even need to write. The 4x, well, that's technically 4x to the power of 1, so we times by the power of 1 out the front, so that just stays negative 4. Then that is x1 take away 1, which is 0. X to the 0 just disappears because anything to the power of 0 is 1. And then the constant at the end just disappears. So there's my derivative. Now we want to find out what the gradient is when x is equal to 3. So we're going to substitute that in. So we're going to do f dash of 3 is equal to 2 by 3 minus 4 is equal to 6 minus 4 is equal to 2. Therefore, the gradient of the point 3, 1, or the tangent to the curve at that point is 2. Right, just some practicing using other notations. So we're told y is equal to x plus 2 all squared. Find dy dx. Now, we haven't taught you a way to solve this as it is or differentiate it as it is. So at the moment we need to expand that. So y is equal to x squared plus 4x plus 4, expanding out the brackets, not forgetting this middle term, so people forget. So it follows on that dy dx is equal to 2x plus 4. Same thing for b here. because we have a variable in the denominator, we can't just do these as individual terms. We need to try and cancel that out first before we can apply the power rule. Pretty much need to have it written as a regular polynomial to apply the power law. So we could say z is equal to t bracket t squared minus 5 all on t. Cancel t's, so z is equal to t squared minus 5. So dz dt is equal to 2t. That's it. Same for example C. We have to expand these brackets. So we get 9t squared plus 6t plus 1 all by the second bracket, which is 2t minus 3. So h is equal to that's 18t cubed. That will work back this way. Plus 12t squared plus 2t. Now I'm going to do the 3, so that's minus 27t squared minus 18t minus 3. Let's group like terms. So we've only got 18t cubed. 12t take away 27t is negative 15t squared, plus 2t minus 18t is minus 16t minus 3. Now we can find dh dt. It's written as a normal polynomial. Times by the power and take one from the power, so 18 times by 3 is 30, 60, no, 48, 44. Hold on, let's just stop and think for a second. 3 tens are 30, 3 eighths are 24, 30 plus 24 is 54. 54t squared minus 15 times by the 2 is 30t, and the 16t just becomes minus 16, and the negative 3 disappears. So there we go. Right. Another one, find d dx of this expression, because it's just an expression. We aren't told y is equal to this. We aren't told h is equal to this. We aren't told f of x is equal to this. We're just given the expression, so it's not dy dx, it's not f of x, it's just d dx. We'll take the derivative of it. It's still the same process. So times by the power, so we get 6x squared minus 10x, and the plus 2 disappears. Right here. So now let's get into a bit of application of this, and this is where all this will become really handy for graphing, especially when you're graphing cubics, because we know how we can find turning points of a quadratic already. We could use that the turning point x coordinate is equal to negative b on 2a. We know that. But it's saying here use calculus. Well, how can we find the turning point? What's special about the turning point of a quadratic? Well, let's think about what's happening right there. What's the gradient? The gradient at that point, okay, or dy dx at that point is going to be equal to 0. Gradient at every turning point is 0. On a cubic, on a quartic, on a quadratic. So if we can differentiate a function and then figure out when that gradient is equal to 0, that's telling us where all the turning points are. So we're given an f of x, so we want to find f dash of x is equal to 4x minus 16. And we want to let f dash of x equal to 0, because that's what we need the gradient to be a turning point. So we get 4x minus 16 is equal to 0. 4x is 16, x is equal to 4. Okay. So that there tells us where turning point is, but we want to find, I guess, the actual coordinates. So we then need to go, well, f of 4 is equal to 2 by 4 squared minus 16 by 4 plus 37 is equal to 2 16s are 32, take away 64 plus 37 is equal to 5. So the turning point is at 4, 5. So that's a really handy thing, and you're going to end up doing lots of this. So finding the derivative, let the derivative equal to 0 because you want to know where a turning point is, and then get the x-coordinates from it. Rightio. 2019 Northern Hemisphere exam 2, so that's tech active again. The graph of fx, blah, 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 has exactly 2 stationary points, 4. Okay. So we need to know where the stationary points occur. Stationary points is another way of saying turning points. So we need to calculate the derivative. So f dash of x is equal to. Now, I haven't done this, but let's just do it on the calculator. Let's get the derivative. So I'm going to define f of x is equal to x to the 3, and let's use proper x's and b's. X just on the keyboard, there we go. X to the 3 minus 6 b minus 2 x to the 2 plus 18 x plus 6. So that's defined. Now we want to do an action. We want to differentiate f of x. Okay, and there it's automatically done it for us. And we may as well actually store that. We're going to store it as define g of x is equal to the derivative of f of x. That's pretty much what that's saying. So there we go. So if we now type g of x, there's the derivative function, and it's got the b's in there where we need it. And we want to know has 2 stationary points. So we want to solve g of x is equal to 0. So we want to know when the derivative is equal to 0, and we want to know what b values will make that work. Will this work? No, incorrect argument. That's right, because we've got 2. This is where we might now write this out since we've got it, is equal to 3x squared minus 12bx plus 24x plus 18. We want to let that equal to 0. We can see that there's a common factor of 3, so we can take that out. So we now get x squared minus 4bx plus 6x plus plus 8 plus 6 is equal to 0. It has 2 stationary points. So if we think about this, this tells us this. We graphed this. We graph the actual derivative. It's a regular quadratic. It's going to look something like that. Okay. Yeah, there's a lot of, and it's question 13, so it's later on the multiple choice, and multiple choice aren't always in order from easiest to hardest, but this is a difficult one now that I've realized how you need to do it, and especially time-wise, 90 seconds. And again, I'm talking through how to do it. But there should have been a giveaway at the very start when it said it has to have 2 stationary points. So this derivative, f dash of x equaling to this equal to 0, that needs to have 2 solutions. Well, when does this quadratic have 2 solutions? Well, that quadratic there has 2 solutions, and I should include the equals 0. That has 2 solutions when the discriminant of that quadratic is greater than 0. So now we need to figure out the discriminant of that quadratic. So the discriminant is equal to b squared minus 4ac. And this is where they love... The Year 12 exam loves to use letters or variables that we're used to using in functions and formulas to add to confusion, because we've got a b here, which actually means all of this stuff in front of the x. Not just this b by itself, it's a different b. Same with the very first problem we did, where the average rate of change is normally written as f of b minus f of a, but on b take away a, but that problem already had an a in it. That was technically where we were going to put b. We would put that a in b. So they love doing this, so you just got to be really confident on using the formulas, what the formulas actually mean. So we need to fix this b component, this bit here, because we've got 2 x terms. We need to take the common factor out there, sort of x, and rewrite that. So we'd have to rewrite this as x squared minus, actually we'd do plus 8 minus 4b x. So I've just taken x out of the common factor out of this middle section. Plus 6 is equal to 0. So now it looks like a regular polynomial, a regular quadratic, our squared, our linear term, and then our constant. So our discriminant after all of that is equal to, that's going to be 8 minus 4b all squared minus 4 by 1 by 6, and all of that needs to be greater than 0 for 2 solutions. So expand this, we're going to get, actually we might leave it as a square, because no, that's square root 24 is not nice, so we will expand it. 8 squared is 64, take away, no, we will leave it. 8 minus 4b squared minus 24 needs to be greater than 0. We 8 minus 4b all squared greater than 24. Square root both sides, so we get 8 minus 4b needs to be greater than plus or minus square root of 24. Running out of space. So 8 minus 4b needs to be greater than plus or minus. Yeah, this is a terrible. Having that plus or minus in there, there's a lot of work in this problem for 1 mark. CAS active, so let's use our CAS. Let's see what it tells us. We can solve inequalities on our CAS. So we have... We have 8 minus 4b all squared minus 24 greater than 0, and we're trying to solve for b. Let's see if it can do that. There we go. It can. So b needs to be less than root 6, negative root 6 on 2 plus 2, negative root 6. Okay, and this is one of those times where if you do use the CAS, you also then need to change the form of it. So we got b less than negative root 6 on 2 plus 2 would be the same as plus 4 on 2, which would be the same as plus 4 on the 2, and the same on the other one. We get b needs to be greater than, try the way it's coming out of the calculator, root 6 on 2. That'll be a plus 4 up the top. Be less than b. Okay, now which of those is that? So this is saying b is greater than the positive root 6, which is that one. And this is b needs to be less than, again, different order, minus root 6, which is that one. So it's e. There we go. That's a mighty hard problem. But it's there. So that's having a real strong understanding of not only differentiating, but then remembering our stuff from quadratics, where this question is telling us we have to have two stationary points. That means when the derivative e is equal to 0, there must be two solutions to that. Therefore, for this situation, if we sort of ignore that it is a derivative, we just know that this thing here in the green box has to have two solutions. Therefore, that quadratic there needs to have a discriminant greater than 0, and solve from there using your CAS. So that's a sort of way to bounce between writing stuff down and using your CAS. Angle to a curve. Find the values for x such that the tangent line to the curve f of x equals x squared minus 2x at f of x makes an angle of 150 degrees with the positive x-axis. We did this in class. I must have forgot to delete that out of the slide in the class one, but we have done that. This comes down from m is equal to tan theta. Any line crossing, or any line crossing a horizontal line, horizontal being the x-axis, or anywhere else, but just with the positive direction, the x-axis needs to make 150 degrees. You can figure out what the gradient of that line is using m is equal to tan theta. So in this case, m is equal to tan of 150, which is equal to, that's the same as 30 over there, so that's 1 on root 3, and it'll be negative. And we want to find the x value when that occurs. We're told that's the function. So if that's the function, then f dash of x is going to be equal to 2x minus 2. And we need to know x occurs when that is equal to 1 on root 3. So you just solve, which we did in class. You get x is equal to negative 1 on root 3 plus 2 all divided by 2. Same as x is equal to root 3 divided by 2 plus 1 is equal to negative 1 on 2 root 3 plus 1. Rightio. For the graph on the right, when is f of x strictly decreasing? So strictly decreasing is when is the gradient going down. So that is from when x is less than 2. When is f of x strictly increasing? Well, that's when the gradient's positive, so that's when x is greater than 2. And give a domain that would make f of x strictly decreasing. Well, we've got it there. X needs to be where x is less than 2. And that would now make f of x strictly decreasing. Find the gradient of the tangent to the curve determined by the function la at the point 1, 1. So we just want to find the gradient. Find the gradient of the tangent. That's just finding the gradient. So f dash of x is equal to 6x squared. Actually, we want to rewrite this as in regular polynomial form, minus x to the negative 2, because we're just taking that up to the top. And then when we do that, that makes it, using index laws, that makes it a negative power. So we can now do f dash of x is equal to 6x squared. Take away times by the power, so that's going to be negative times by negative 2, 10 plus 2x to the negative 2. Take away another 1, becomes negative 3. And we want to find it at point 1, 1. So we just need to find f dash of 1 is equal to 6 by 1 squared. 2 by 1 to negative 3, which is equal to 6 plus 1 to the power of anything just stays 1. 2, so the gradient at that point is 8. Rightio. I made a mistake with this one. This one you can't do yet because we haven't done the chain rule. Yeah, this is technically a chain rule because we could rewrite this as f of x is equal to 3x to the minus 1 to the power of negative 1. And yeah, this is technically a function inside a function, so my apologies, you won't be able to do this one yet. Tech free, so you couldn't even just jump on your calculator, even without knowing chain rule. So yeah, we'll leave it for now. Find the gradient of tangent of the curve f of x is equal to x to the power of 3 on 4 at the point 16, 8. So the power rule still applies, just multiply by the power, so 3 on 4, x, take 1 from 3 on 4, so 3 on 4 take away 1 is the same as 3 on 4 take away 4 on 4 is equal to negative 1/4, which we could rewrite as 3 on 4 to the x to the 1/4, which is equal to 3 on 4 times by the 4th root of x. So there's that derivative function. We now need to find f dash of 16, which is equal to 3 on 4 to the 4th root of 16, equal to 3 on 4 times by the 4th root of 16 is 2, I'm pretty sure. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's times 2 is equal to 3 on 8. So the gradient at that point is 3 over 8. And again, we need a chain rule for that one, so we can't do that problem yet either. So there's the solutions to all the practice problems. By far, that one is the hardest. That's one of those ones when you first look at it, you're like, oh yeah, maybe not too hard, and then you get into it, and that's one of the ones that you should alarm bells. You hit your 90 seconds, or maybe you should probably actually give yourself 2 minutes maybe for a multiple choice, even though each work out to 90, because some are pretty easy that you can get really quick. But yeah, you hit 2 minutes for a question, you're like, okay, I need to leave this and come back later, especially if you're just trying to grind it out, pen and paper. But that's it. See you later.